Good morning, my lovely 13s. Right, buddies, here we go again. We're back onto the online learning again. At least we're well practiced at it at this stage. I think that, yeah, we'll do really well with it. You're going to be really good at it. Cool. So today is a very exciting day for me, anyway, because it's our first day of mechanics. So yeah, this is like one of my very favorite things in maths. Which is funny because it isn't maths at all. It's a miracle that I get to teach it in maths because this is physics. But it's really good though, and we're going to really enjoy it. So our first unit in it is in our mechanics course is a dynamics unit, and it's going to be about forces. The title today is Resolving Forces. Now, in case you're interested, because I bet you are, it's called mechanics is actually the combination of two subjects, kind of like, maths has algebra and number and shape and stuff like that. Well, when you're talking about mechanics, it's actually a broader field. It's made out of two things. It's made out of dynamics, which is what this is. That's like forces and how you apply a force and the acceleration it causes. That's what causes. That's dynamics. And the other one that you remember from last year, SUVAT and stuff like that, that's how things move. That's called kinematics. So yeah, that's what mechanics is. How exciting. Okay, speaking of formulas, do you remember these guys from last year? Badoosh, there they are. Okay, there's only two really formulas that you need to know today. And the first one is F net equals MA. Now, depending on who you had last year, i.e. anybody who isn't me, you won't have had the net on it, you'll have just had F equals MA. And while that is kind of true, I find that a little bit complicated. So I'm going to try to convert you to my way because I think this mechanics stuff is actually quite easy. And I know that people find it really, really tough. But oh my gosh, I can turn every mechanics question into like one of three sorts. And so you'll get the exam at the end of, I suppose you won't get the exam at the end of the year, but you'll get like a test or whatever. And you'll be able to be like, oh yeah, it's that type of question and just bust it through. So anyway, I'm going to convert you to my way. How exciting. So three equations that we're going to have, or two equations even. F equals ma. Now F net equals ma because it's the overall balance of forces that's equal to the mass times acceleration, not kind of every given force, even though every given force is derived that way. Cool? And this one here, W equals mg, that's the weight of an object, okay? That's kind of how heavy something is. That's the Earth's gravity pulling on something's mass. So you need to know that the Earth's gravity is 9.8 meters per second squared. That's the speed that things fall down toward the Earth. It's not a constant speed, but this 9.8 to two significant figures is pretty decent and pretty accurate near the Earth's surface. It's less accurate, say, even on Mount Everest, it's not quite that. And if you were to go toward the center of the Earth, it would be more than that kind of thing. So it's a funny old number that, but it's derived from a bigger thing, which you'll learn about in a physics lesson. But we'll use G equals 9.8. It's cool. Yeah, cool. Right. So I've picked a harder question to start with, and let's do it. Let's see if you can remember. Okay, here's what we've got. It is a box of mass 8 kilograms lying on a smooth horizontal floor. Okay, whenever you see some, drat, I just clicked the wrong button. Whenever you see the word smooth in a question, that just means that there's no friction, okay? So it's a frictionless surface, and it's on a horizontal floor. A force of 10 newtons is applied at an angle of 30 degrees. Now this 30 degrees is what separates this question from a year 12 question. So it is a year 13 question now, simply because the force is at an angle. It's not going to be any bother to us at all, though. You're going to love it. And it causes the box to accelerate horizontally along the floor. Calculate the acceleration of the box. Now, I want you to do this exactly my way, even if you think you can do it faster your way, because I want you in a pattern, and yeah, I want you in a pattern. So I'm going to need you to try to show this, to try to do this way. I promise you, it'll make you really good at these. Okay. Now the first thing in every single mechanics question is we're going to have to draw a picture, okay? And because this is a dynamics question, we're going to be drawing what's called a free body diagram. So even though the picture's already drawn there, we're going to redraw it just kind of down here, okay? Because we want one to write on, and I have it on my screen, but you haven't got it drawn yet, so you're going to draw it too. Now, here's what you do. Draw the little square just like that. Put the 8 kilograms in it just like they've done. So you always put the masses inside of the square. And now we have to draw every single force that's acting on this picture. So one of them's quite clear. We got this one straight away because it's actually included. You've got this force that's on an angle and it's 10 newtons, okay? 10 newtons, if you're not sure what 10 newtons would feel like, that's like if you were to hold a bag of sugar in your hand, okay? So if you were to like take your old standard bag of sugar, a kilogram bag of sugar, and hold that in your hand, that's about how heavy 10 newtons is. That's what 10 newtons feels like. Cool? Right, and that's 30 degrees here. Cool beans? Okay, now is there any other forces acting on this? Well, indeed, yes, there is. If it is on the Earth's surface, sat on the floor, it's going to be affected by weight. Just like you sat in your chair right now, should feel, hopefully you feel pulled toward the Earth, and this is something wrong with you, and you feel like you're sat on your chair. It's because you're being pulled toward the Earth. But at the same time, though, you're not flying through your chair, are you? You are being supported by your chair, and that's because the chair is pushing up on you. This is called a normal contact force, and they give it the letter R, and that's because it's called a reaction force. So because you push down on the chair, it pushes up on you. So you have a force that's in the opposite direction to the weight. So happy days with that. That's a reaction force. It's always perpendicular to a surface. Cool, cool, cool. Now, is this box accelerating? Is pulling on it with 10, is there friction? No, there isn't because it's smooth. Now here's what it's asked us to do. It wants us to find the acceleration. So the box is accelerating. Which way will it accelerate? That's right! If you said it's going to accelerate to the right, you're right, because it is being pulled to the right. The way you show that is a straight line like this, and 2 little arrows on it. 2 of them shows acceleration. And just label that A, because we don't know it. See that there, buddies? I know I talked, it took a long time because I was yapping, but that will only take you a couple seconds to draw, I hope you agree. And that is like key to unlocking all of these amazing questions. So that's, yeah, you're going to draw a picture every single time is what I'm getting at. So you're going to draw me this all the time. So get used to it. Hey, okay. Now work out at the acceleration of the box. Here's where it's different to your 12. This force is at an angle, so it's not in a horizontal or in a vertical direction. Here's what we're going to do. We're just going to take our force and we're going to break it into what is called components. Okay? So here's what you do to break it into components. You're going to do this. You're going to go dash, 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 dash along the horizontal. And then you're going to go dash, 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 dash up in the vertical. Because you'll see that these now are at a right angle to one another. Cool? Now, I'm just going to do this just because it's going to help in the future. I don't need to do this, but I'm going to. I'm going to give this force a name. Instead of calling it 10 newtons, I'm going to call it F equals 10 newtons, okay? F for force. Okay? Force equals 10 newtons. Which means that I can call the red one, which is going up, I can call it FV, the force in the vertical. I can call the one that's going across, what will I call that? That's right, FH, force in the horizontal. Because here you go, you're about to become bosses doing it my way. Here's what you do. It asks us to find the acceleration. Is that in the horizontal or the vertical direction? Well, the horizontal, because you can see it's there. So here's what you write. You write hor, like that, for horizontal. Which way would you like to be positive? Well, it's accelerating to the right. We'll have right as positive. Cool? Underline that. Now here's what you're going to write underneath it. We want to do a balance of forces. What this is called an F net equation. So you're just going to write this. You're going to write F net, the overall forces, is equal to, and what forces do we have in the horizontal direction? Well, not R, not W, because they're up and down, they're vertical. We're going to ignore this diagonally one because it's in both directions, but we will look at the red. We have FH in the horizontal direction, but not FV. So F net is just going to equal FH. Cool beans? Yeah. Okay, now F net, you know, my buddies, that's going to equal MA. Because remember, we got that formula. Where is it? It's just a little bit above here. F net equals MA, right? So we're going to swap F net out for MA. And our FH, we don't know anything about FH. But what we do know is we know that, I'm going to grab a different color here. What we do know is that we know that cos of 30 in that right-hand triangle there is equal to FH over F, which is 10, which means that FH is equal to 10 cos 30, which means what we're going to get in here is just 10 cos 30. Cool beans, buddies? Do you get that? Do you get that? You don't have to show the step I did in green. I only just showed that so that you would know. So you can go straight to 10 cos 30 straight away when you realize, oh, it's cosine because it's adjacent and always the hypotenuse is given. Cool. Now have a little look at your picture. Do we know what m is? Yeah, it's 8. So we'll put this as 8. Do we know what a is? No, because that's what we want. So it's 8a equals 10 cos 30. Now, you don't even have to show a step here, okay? You've got all the method marks just by laying it out like this. So if this was worth a few, you've got them all now just by writing it out my way. And now you're going to go a equals, and there's no method for workings out. So bish, bash, bosh, all into your calculator. So I'm going to type 10 cos 30, and then I'm going to close that, and I'm going to divide. Then I'm going to go divide by 8, then I'm just going to do it in one step. And it's physics now, so we're not going to have to do this with surds and stuff. We'll just go for a decimal number, which to 3 sig fig is 1.08. 1.08. Now the units are meters per second squared. Because I laid out my sign convention above, because I said that right was positive, and I achieved a positive answer, that's it. It's to the right. I'm done the whole question now. Boom. How cool is that? Very cool. Okay, sweet. Now I'm going to do B as well. And for B, it's going to be the same deal. And guess what? I've already got the picture, so it's going to be lovely. For B, it says, calculate the normal reaction force, the normal reaction between the box and the floor. Oh no, what's a normal reaction? That's right, it's the R, my lovelies. That's what we're going to be on about. So guess what? Because you've got my method down now, you're going to be beastly good at this. So you say, where's R? And it's there, it's pointed up. So are we talking vertical or horizontal? Well, vertical. So you're going to write this. You're going to write vert. You're going to choose a direction to be positive. It makes no odds, but R is up, so we'll choose up, how about? Because that means that our answer will come out as positive. It's just easier to work with. Now vertically, we're going to do the same deal again. You always write F net equals the balance of forces equals. And which ones are going up? Well, R is certainly going up. FV is going up, so we'll put plus FV. And any others up? No, but W is going down. Take W. Cool. Now next step. F net, you know, is equal to MA. Is it accelerating vertically? Will it leave the surface? Well, no. So the acceleration is 0, so F net is 0. So that's how you skip a step by writing that. So you'll write 0 equals, and you'll go R plus. Now FV, what can I swap FV for? Well, if you said 10 sine 30, you're absolutely right. Sine because it's opposite, 10 because that's the hypotenuse of it. And weight, well, weight's mg, okay? And you can cut a couple steps down and you get a little bit better at this. So now go to the next line. 0 equals r, which we don't know, but that's what we want, so that's good, plus 10 sine 30. And just pop the last two numbers in. The m is 8. Open bracket, put it in its bracket all by itself, and 9.8. Open and close brackets in brackets all by itself. Don't use times, okay? That's going to muddle you if you do that. Put them in brackets just like I've done, okay? My God, you're going to be good at this method. Now the rest of the steps you don't have to show. Just bish bash bosh it in the calculator, get the answer. So it's going to be 8 times 9.8. Take away 10 sine 30. And I've got an answer of 73.4. 73.4. Now R is a force, so we're dealing in newtons. And that's it. Bish bash bosh. I am aware that this isn't exactly the way that you may have done it last year, unless you had me. And I'm also aware that this is probably 1 or 2 more steps than the way you did it last year. But I promise when it gets harder that my method will never, ever, ever fail you. And it turns every single question to the same question, which is awesome. Cool? So that's that. Cool. Harder. Here we go. Okay. Now this one here is just, this is not actually a very physicsy question. This is more about a theory question. It says this. It says 2 forces, P and Q, act on a particle as shown. P has a magnitude of 10. I am gonna make this no, I'm not. I'm not gonna be a bad example. I'm not gonna steal the picture. Okay, P's got a magnitude of 10. and Q has a magnitude of 8. Now it says, and this is a tricky one, work out the magnitude, the size, and the direction of the resultant force, which means when you put the two together, what do they make together, okay? So if you were to pull P and pull on Q, well, certainly they're both pulling toward the right, so it's going to end up going toward the right, and this one, I don't know, it might be like that. That might be the direction it goes, but we don't know that yet, okay? So here we go. Let's do this exact same way we did last time, okay? So it's a theoretical question. It's not on the table. There's no weight. There's no reaction force or anything. It's just theoretical, okay? So here's what we're going to do. We're going to sketch this picture out. Oh, just for the sake of the video, I'm not redrawing it, okay? I know I should, but I'm not going to. You need to draw it, though. And here we go. From this picture, which I've grouped to that, so I also can't do that, here's what you're going to do. We're going to break it into components, okay? It did say that P was 10, so I'm going to put P equals 10 newtons on that, and it said that Q was 8, so Q equals 8 newtons. I'll only ever put the units there as well. I'll never put them in my calculation. And here's what we're going to do. They're both on an angle, so let's break them down. So for P, we're going to go along like that, and we're going to call that PH, because that's horizontal. PV. Oops. Ooh, where's the pen? PV. PV, because that's vertical. Cool beans? Same deal on the Q one. Along like that. That's going to be QH. Down, 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 down. QV. Cool? Cool. Right. Well, here's what you're going to do then, guys. Let's first of all figure out what the overall effect of these forces are going to be. Now we're going to consider each direction first. Let's do horizontal first. So what do you write? You write hor for horizontal. Which way do you want to be positive? Well, definitely to the right, because both of them are pulling toward the right in terms of up and down. Now here's what we're going to do. F net, every single time. The balance of forces is equal to. And what are the two ones that are going, what are the two forces that are acting horizontally? Well, it's PH, and we're going to go plus, because they're both acting to the right, QH. Okay? Now, this question, normally you'd swap F net out equals, you'd normally swap F net out for MA, but in this case, we're just going to leave it as F net, because it wants a force in the end. So F net equals, and I'm going to go a little bit quicker now, this is going to be 10 cos 45 plus 8 cos 30. See if you can get that from the triangles, right? From sine and cos and the triangles, which means F net horizontally is going to be those two together. So it's 10 cos 45 plus 8 cos 30 equals, and nice surd answer, but we're a physicist now, so we don't need to worry about surds. I've got 14.0 newtons, and that's my answer for horizontally. So altogether horizontally, it's being pulled by 14.0 to the right. But the thing is, though, it's being pulled up and down, too. So you write vert. Pick a direction to be positive, up. You can put down if you want. I'm going up, though, because I'm positive. So here we go. F net equals. And here we've got, which one's going up? Well, PV. But QV is going down. So what do I write? Well, take QV is right. I hope you see that. Do you see that, buddies? So you take it away because it's downward, and we said upward was positive. Cool, same deal as last time. F net equals, this is going to be 10 sine 45, take away 8 sine 30. The sines are from opposite in SOHCAHTOA in the triangles, which means vertically our overall balance of forces, I almost hope that this is negative, I don't think it will be though. 10 sine 45, take 8 cos 30, give me negative. Oh, positive. Gosh, I'm too good at this. So 10 sine minus 8. Oh, shoot, sine. Yeah, no, hang on. I typed it wrong. Sorry, buddies. I typed it wrong. I put in cos and not sine. 8 sine 30. I was like, that's too small of an answer. Oh, there we go. Right, 3.07 is what I've got now. Looks better. 3.07 newtons. Cool? So, in other words, my sign conventions were right. It is up, so the total movement is up and right. Now here's the thing. We need to put them together though, okay? Because we want to know what they are together. So we're going to put them together. Yeah, together. I was going to write combine. I got confused. I'm going to write combine instead. Combine! Here we go. Okay. Now, what we've got then is we got the 14 newtons, and it's off to the right? So let's draw it first. That's the 14 newtons from the red. Now, for the blue, I mean. Now, from the red, we have 3.07 up. And so our resultant one is actually the combination of those two. So our resultant is going to be this, which I'm just going to call F, I guess, because we haven't used F, and F stands for force. So there you go. Well, how do I get F? Well, you lucky ducks, it's a right angle triangle. So how are we going to get it? With whatchamacallit, that thing from year 9. Pythagoras' theorem, that's the one. So we're going to do it. F equals, what's going to be the square root of 14 squared plus 3.07 squared, which gives us that F equals, and let's do it, square root 14 squared plus 3.07 squared equals 14.3 up to 3 significance figures, 14.3 newtons. The overall force is 14.3 newtons. Now it also wanted the direction. To get the direction, it's on about an angle. So the angle we're going to go for is this angle. Put theta in there, because that's a really good place to have it. Well, let's get that. Tan theta, 3.07 over 14. Hopefully that's okay. Just SOHCAHTOA. Theta equals shift tan 3.07 divided by 14 equals 12.4 to 3 significant figures. Cool. Now that answers the question, but if you want to be completely lickety-split like a physicist would be with this, because this is a physics question after all, here's how you'd write your final answer. Final answer would be this. You'd write this. You write then the force equals, the overall resultant force equals 14.3 newtons, open a square bracket, and you have to write this actually, so I shouldn't have said only physicists, you have to do this too. And you're going to write down this. You'll write 12.4 degrees, and you'll write above horizontal. Okay? And that is the answer to the question. The square brackets is a physics thing, but you still have to write it just like that. Okay? So that's really neat. That answers the whole question, and boom, look at you. Maths and physics together. Amazing. I hope it's okay. Yell at me in the chat if it isn't okay, though. Okay? Now, I kind of want to end the video, but I think I'm going to do this thing anyway. I'm going to do it one more time. Okay, that's how you should do it, okay? That's the best way of doing these questions. You should try to do them all that way. Here's the same question again, and there's an alternate way of doing this, but the trouble with it is I've seen one example in my whole life where you have to do the stupid way that I'm about to show you, but I felt really bad because the kids who I didn't teach that way to actually got it on their exam, and so only those who could figure out the way without being taught got the marks. So I'm going to make sure from now on it's my way to tell you I have to show you this. This is called the method of triangles, which I'm going to do for you now. It's not very good. I'd advise not using it unless you absolutely get boxed into a corner, but let's do it anyway. Okay. Method of triangles is a stupid way, but we're going to do it. Here's what you have to do. If you're going to do method of triangles, when you put forces together, what you're going to do is you always have to lay them tail to tip. So here's what you do to start with. Redraw P. So yeah, this is the method of triangles. Redraw P. So here we go. P or Q, it doesn't matter. I'm starting on P though. Okay, there's P right there. Okay, P was, what was P again? 10. P equals 10. I'm going to even ditch the newtons. P is 10. Okay, we had a little angle given with P as well. That was 45 degrees. Okay, and now what we're going to do is we're going to redraw Q, but we're not going to draw Q where it started, here acting on the force, but at the end of P. So it's a bit like the vectors that we've done this year and last, that you stack them tail to tip. So just redraw Q there. Okay, like that. Okay, now Q is equal to 8. And what you found with Q is it had this angle given along the top like that, I think, didn't it? So that's 30 degrees, Okay, so its angle was given along the top. So we've just redrawn them, but yeah, together kind of thing, if that makes sense. So here's what we are gonna do with this monstrosity. What are we gonna do with this monstrosity, my lovelies? Well, you're gonna start off here at the very end, starting at P, and you're gonna draw. I'm gonna redraw Q. I don't like where I've drawn Q because I'm gonna make my picture too hard otherwise. Oh, I'm worried I'm gonna make it too hard. I don't want to break you. I don't want to break you on the first one. I'm gonna draw Q as a lot longer than I did, okay? This is why this method is stupid. Okay, I just made Q longer because it's going to make the question easier to see. So don't worry though, it's going to be the same answer. So Q equals 8, there's what we got. Our resulting one is from the start of P all the way to the end of Q like that, okay? I'm going to call that F, and it's tail to tip from that one. Now, here's the loveliness of it, my lovelies. What we have to do now is we have to be able to essentially try to figure out how to use sine law and cosine law to get what F is. Now, I don't love this way, but what the heck, shall we do it anyway? Okay. Yeah, time to fight with it, my lovelies. Do whatever you can to get some angles in there. We don't have a single angle inside the triangle. We've got 8, we've got 10. That 45 isn't the whole way, so we need to start fighting it. So let's start fighting, buddies. Okay, let's do it. That's 30 there. That means if we drew like a compass point like that, like a bearing, that'd be 60 degrees, because that would equal up to 90, so we have half of that. If I did the same on this one, if that's 45, that's 45. Oh yeah, okay, that's the trick to it. And can you see? We've got a zangle, my lovelies, an alternate angle. See? It's a Z. This method's rubbish, isn't it, though? I don't love it, but it's, I don't know, it's not rubbish. It's a different way, I guess. And so that's 45 degrees. Cool beans, buddies? Cool. Well, if that's 45 degrees because of the Z angle, then altogether, both of these bad boys together are 105 then, when you put them together. So that whole bit from there to there is 105. And now look, it's like a cosine law triangle, right? Because here's your cosine law bits. I'm going to erase the coloring in I just did there, so it'll make it easier to see, I think. Get rid of the yellow. Okay, sweet. Look, it's a cosine law thing. There's a 10, there's an 8, there's 105. There's the thing you want at the end, okay? Treat it like a cosine law triangle. So in cosine law, we got this. We're going to have c squared equals a squared plus b squared. Take 2ab cos c, which means we're going to, oh yeah, write it then. C squared equals a squared plus b squared. Take 2ab cos c. Cool. And c is the side opposite. So in ours, it's f squared equals, and what you're going to get here is a squared, which is 10 squared plus 8 squared. Take 2, 10, 8 cos 105. Okay? And now bish bash bosh in your calculator one step, and it better be the same answer, so help me. 10 squared plus 8 squared. Take 2 times 10 times 8 cos 105. Oh, thank God, square root answer. Huh. Equals 14.3, thank God. Okay, 14.3 newtons. So that's what you got right there, my buddies. I had above horizontal on this one, didn't I? Vertical up and right. Okay, and that's cool. That's what we've got then as our magnitude, which we have right. But then here's another shortfall. Here's another shortcoming of the question, I'm afraid. We need to get the angle that it's at, but I've drawn the picture badly. So remember when I erased it at the start? The F is actually going to be pointed up a bit more like that, okay? So I drew the picture badly. So the angle I get, I would have got a negative angle there. So I wouldn't have got the bearing thing right. But yeah, what you're going to do, oh dear, I don't love this method. What you're going to find is next thing that you would do, let's pretend I did draw it right. Let's pretend it did match up to how it should have done. You'd just have to find this angle in here next. And if you did that, say you got like 10 degrees or whatever, it'd be 10 degrees below horizontal. Now the real answer is 12.4 degrees above horizontal, which all that means is I drew my F in the wrong spot. My F points upward, like how I had it before. But yeah, I've shown you it now though, so basically this is an okay question. If you followed through on it, you would have just got an angle that didn't match up with this, but you would have got the right answer anyway. It would have made sense in context if you finished it. So, again, there you go. You can do it that way. That was a bit better, I think you'd agree. And this is a normal physics question. So here's what I think you should do. I want you, in the remaining time, and whatever time you would have spent on homework, to do page 95, question 5 to 9 first, because those are the real physicsy ones that the exams are like, and then question 4 second, okay? Do your best, get as much done as you can, and really good work. Yell at me in the chat if you want help with anything. I'm happy to do another one with you or to look at your work. And that's that. So see you next time, buddies. Bye, buddies!